Today we're going to be talking about exponential equations and graphing them. So first we got to figure out what an exponential equation is. And every exponential equation is going to have the formula y equals a times b to the x power. So that x is in the exponent here. Okay, the variable is in the exponent for an exponential equation. And that's a lot like the geometric sequences that we had just been seeing. Instead of having the n minus 1 power there, we're going to have just the x power. So let's look at some examples of what this would look like. We could have y equals 2 to the x power. We could have y equals 3 times 4 to the x power. We could have y equals 14 times negative 1/2 to the x power. And you notice I put parentheses there, so you could technically put parentheses around any of these. That b value could have parentheses around it as you go. But those are all exponentials. They have a variable in the exponent. So the first thing we're going to work on doing is evaluating exponential equations. And so we're going to deal with f of x equals 2 to the x power, and we're going to evaluate it for these values. -3, 0, 1, and 6. And all that's telling us is what the domain values are, what the x values are that we're plugging in. So the first thing we're going to do is find f of -3. That's the first value they give us here. Well, that means that we're going to plug 3 in for that x. Sorry, -3 in for that x. And so we can just type this into the calculator to get our answer. So we have 2 to the -3 is going to give us an answer of 0.125. Now it asks us to evaluate it for 0. So we're plugging in 0. We have 2 to the 0 power, and we should know that anything to the 0 power is 1. So that one I don't even need to plug into the calculator. The next domain value we're plugging in is +1. So we're plugging that in where we see the x, and 2 to the first power is just itself. So when evaluating it for 1, you get 2. And the last thing is to plug in 6, and 2 to the 6th power is 64. And again, you could have used the calculator for this, but those are all things that you should be able to figure out without using the calculator. So to evaluate, all you have to do is look at what values they tell you, and you're plugging them in for the x in the exponent. Alright, so let's look at this one. We have y equals -3 times 1/2 to the x power. We're evaluating that for just 3 values here, -2, +1, and +3. So if we have this, you could also write this as f of x equals, remember that. So if we're plugging in x equals -2, we have y equals -3 times 1/2 to the -2nd power. So let's plug that in here. You technically don't have to put the 1/2 in parentheses. It would still read it the same. I just like to make sure that I'm keeping track of things. And that's telling us that when we evaluate this at -2, we're getting an answer of -12. The next value we're plugging in is a +1 for this. So let's talk about this. 1/2 to the first power is just 1/2, and then multiplying that by that -3 is -1.5. And if you don't trust your math skills of things, you can always double check it in the calculator, okay, by just going in and changing that -2 exponent to a +1. And then the last one that we're plugging in is x equals 3. So when we do that, we're getting -0.375. And since we're having this 1/2 as our b value, it does make sense that our number should be getting smaller as we're going here. So that fraction goes to a higher exponent, it's going to be becoming a smaller number, and so then multiplied by -3 is going to become a smaller number as well. So that's how we evaluate exponential equations. We're going to use that evaluation to graph exponential equations. So when you're doing this, you're going to be given an equation, and you're going to be asked to graph it. Every single one of those, we're going to make a table of values for the values -2, -1, 0, 1, and 2. And we're choosing those just because they're relatively small numbers, and with exponentials they can get really big really quick. So we want to choose something that makes us have smaller numbers to be able to graph on a graph that is of this size. So we're going to make a table for those, and then we're going to plot all 5 of those points and connect them. Okay? So let's go ahead. We're going to make our table here. So we're going to graph y equals 3 times 2 to the x power. And again, we are going to have these 5 values. You technically could choose any 5 values that you want to plug in, but this is going to, again, keep the graph small for us. So if we do this and plug in those values, so this one we're going to get 0.75. And I'm doing this the exact same way that we typed in those other ones from the previous examples. We're just getting what those values are. Okay. I know if I plug in 0, that's going to make that be 1, so this would be 3. Plugging in 1 to this, 2 to the first power is 2, times 3 gives us 6. And then 2 squared is 4, 4 times 3 is 12. Okay, so you don't even need to use the calculator in order to do any of these. And then we're just plotting these points. So we're plotting the point -2, 0.75. So you're just doing the best that you can to figure out where that 0.75 or 3/4 is. -1, 1.5, 0, 3, 1, 6. And then even this 212 is going to be off of our graph here. So it's going to be somewhere about right there. We're going to estimate. So we're going to take those. We're going to connect those points. Now, these will continue to get smaller and smaller and smaller, closer and closer and closer to that x-axis, but it's never actually going to touch it. And so this is where you can even type into Desmos. I'll bring the calculator up here again. Let's put it up here. You can type in that equation again. So we had 3 times 2 to the x power, and then you can see that ours looks exactly like that does. Okay, so that's a way that you can also check with Desmos in graphing your exponential equations.